In this section, we're going to learn how to graph linear equations using an XY table. I don't want to scare you guys though. Linear equations is really just a fancy way of saying lines. Okay, so we're going to learn how to draw lines using an XY table. First of all, what is a linear equation mathematically? So a linear equation is an equation of the form ax plus by equals c, where a, b, and c are integers. The set of all ordered pairs that are solutions to a linear equation form a straight line. That means that everything that fits inside of ax plus by equals c is a straight line. So how do we graph our lines? Well, we wrote down our steps here, so let's go ahead and read them. Step 1 is to create an XY table. Step 2 is to pick points for either the x or the y, and we want to pick 2 or 3. Step 3, solve for the other variable. Step 4, plot the points. And step 5, graph the line. Alright, let's practice doing some of these. Our first example is y equals 2x minus 6. So I'm going to do an XY table right here. Now I can pick anything I want for either x or y, but looking at this equation it seems like it's easier to plug in things for x and then find y. So I'm going to go ahead and try some values for x. Maybe first I'll try 0, then I'll try 1, then I'll try 2. If you want to be absolutely safe when you're drawing your line, make sure you do 3 points instead of 2. So when we plug in x equals 0, we get 2 times 0 minus 6, which is 0 minus 6, which is negative 6. If I plug in 1, I get y equals 2 times 1 minus 6, which is 2 minus 6, which is negative 4. If I plug in 2, I get y equals 2 times 2 minus 6, which is 4 minus 6, which is negative 2. Let's go ahead and draw a picture of these. 0, negative 6 is 1, 2, 3, 4, 5, 6. It's down here. 1, negative 4. Remember we go 1 to the right and 4 down. We are right here. And then 2, negative 2 means we go 2 to the right and 2 down, so it looks something like that. And we can see that these three make up a straight line. Let's go ahead and label these, by the way. This one's 0, negative 6. This one is 1, negative 4. And this one is 2, negative 2. So this is all that entails in graphing lines. We need to just create a table and try to get at least 3 points that are on there. Let's try another one. X minus 3y equals 3. We're going to do our XY table here. Now looking at this problem, in this one it seems like it's easier to plug in for y instead of x. Okay, so let's go ahead and plug in things for y. I'm going to try the points, this time I'll go backwards. How about 0, negative 1, and negative 2? So if I plug in 0 for y, I get x minus 3 times 0 equals 3, or x minus 0 equals 3, or just x equals 3. If I plug in negative 1 for y, I get x minus 3 times negative 1 equals 3, or x plus 3 equals 3. And if I subtract 3 from both, I get x equals 0. For the next one, if I plug in negative 2 for y, I get x minus 3 times negative 2 equals 3, or x plus 6 equals 3. So if I subtract 6 from both sides, I get x equals negative 3. So that gives me 3 points, right? 3, 0. Let me go ahead and draw that one. 3, 0 is right there. 0, negative 1, that's right here. And then negative 3, negative 2 would be right here. Notice that these do form a straight line. Let's go ahead and connect the dots here. I recommend doing this with a straight edge. Let's go ahead and label our points. Negative 3, negative 2 is there. 0, negative 1 is there. And 3, 0 is there. By the way, we have two special points that appeared here. Since this point lies on the y-axis, this is called the y-intercept. And this point right here, since it lies on the x-axis, is called the x-intercept. These are special points. It's where the line crosses the x and y-axis. In fact, maybe for this next example, we will practice finding those on purpose instead of getting lucky like we just did. Okay. So for this next one, number 3, we're doing 3x minus 4y equals 12. What I'm going to do is I'm going to do 0 for x and 0 for y. We're doing this so we can find the intercepts instead. If you recall in the last problem, 0 was what we had for x and y. So let's see what we get. If we plug in 0 for x, we get 3 times 0 minus 4y equals 12, or negative 4y equals 12. Divide both sides by negative 4. I get y equals negative 3. And if I plug in 0 for y, I get 3x equals 12. Divide both sides by 3, I get x equals 4. So 0, negative 3 is right here, and 4, 0 is right here. So this gives us our line. Remember, this point is 0, negative 3. This point is 4, 0. And this one would be the x-intercept, and this one would be the y-intercept. For our last two examples, things get a little weird, right? Let's look at number 4. It says x equals 3. Well, notice that there's no y's in the problem. Now, that doesn't mean that y is not there. It actually means that y can be whatever you want. And in fact, it tells you that x is always 3 no matter what y is. Which means if I make y 0, I get 3 for x. If I make y 1, I get 3 for x. If I make y negative 2, I still get 3 for x. I always get 3 for x. Let's go ahead and plot these points. 3, 0 would be right here. 3, 1 would be right here. And 3, negative 2 would be right here. So if I connect these dots, I get a vertical line, don't I? This is 3, 1, 3, 0, 3, negative 2. Notice that this is a straight up and down line. Let's try one more. In this one, y is always fixed. That means no matter what x is, y is always going to be negative 2. So when x is 0, y is negative 2. When x is 1, y is negative 2. When x is 2, y is negative 2. Let's try drawing this to see what happens here. 0, negative 2 would be right there. 1, negative 2 would be right there. 2, negative 2 would be right there. We get the following. Let's go ahead and label these points. Those are the 3 points that we get. This is actually a horizontal line. So what's the catch here? Or what's the lesson we get? When there's no y's in the problem, like number 4, it's actually a vertical line. And when there's no x's in the problem, like number 5, then it's a horizontal line. Thanks very much for watching. I hope that this was useful and that you can now graph lines. Good luck.